Welcome to The Explainer. Today, we're taking on a genuinely fascinating challenge. We are going to completely demystify the fundamental building blocks of our universe. For decades, we've been taught to look at particles through the super abstract lens of quantum physics, right? We kind of imagine them as these weird, untouchable mathematical ghosts. But what if, just what if, we looked at them through the lens of tangible mechanical engineering instead? What if the universe, at its absolute smallest scale, is way less about abstract math and more about actual physical geometric structures stretching and spinning? Well, that is exactly what the resonance framework proposes. And today, we are going completely under the hood to break it all down.
Okay, let's dive into this explainer's roadmap. We're going to completely dismantle everything you thought you knew about particles. We'll go from points to resonance machinery, check out the particle's sustenance engine, connect radius, volume, and mass, look at the three particle generations, and finally, wrap it up with the quantization mystery. Let's get right to it.
All right, part one, from points to resonance machinery.
So to really grasp this massive paradigm shift, I need you to challenge your own preconceived notions for a second. What exactly is a particle? Literally, if you close your eyes and picture an electron or a quark, what do you actually see? For the longest time, the standard playbook has been to define a particle as a zero-dimensional mathematical point, just a tiny floating dot with absolutely no physical volume and no internal structure. But let's be real. Physically speaking, how on earth can something with zero dimensions possess mass, spin, and energy? It just doesn't add up. And that brings us to a really stark contrast between two entirely different ways of viewing reality. On the left, we've got the old paradigm, treating particles as zero-dimensional abstract mathematical points, and hey, it works great on a chalkboard, but it leaves us with these massive, profound physical mysteries. Now, on the right, we have the new paradigm we're exploring today. This is where we view a particle as a literal mechanical resonance that is highly localized within the physical spatial fabric. So in this model, space isn't just some empty void where particles float around like dust motes. The spatial fabric itself is the actual topological substrate for all physical phenomena. A particle literally is the fabric, just structured in a very specific resonant way.
To really get this, we need to introduce a new term. Enter the carrier ball. Now, this isn't just a metaphor, okay? It's a literal mechanical component. A carrier ball is an organized geometric resonance structure within the spatial fabric itself. It functions as the absolute fundamental physical unit of a particle. Think of it like a localized deformation. The spatial fabric is physically bent, twisted, and organized into a highly specific geometric shape. So a particle is simply a complete carrier ball construction. But since space naturally just wants to be flat and perfectly undisturbed, how does this complex geometric structure survive against the fabric's natural equilibrium?
Well, that perfectly tees up section 2, the particle sustenance engine.
So particles, at least in this resonance framework, are absolutely not static objects just sitting lazily out in space. No way. They are incredibly dynamic, constantly struggling systems, and they are kept alive by something called a Belchik rotation. This is a continuous, ridiculously high-frequency internal topological motion. It literally acts as the sustenance engine of the particle. Without this mechanical work constantly pumping, the localized fabric deformation would just instantly untangle back into flat space. Think of a super tightly twisted rubber band forcefully snapping back into place. This rotation is the strategic engine for fermionic behavior. It's literally what establishes the particle's very identity and physical presence in our universe.
But here's the catch. This Belchik rotation isn't happening in some magical vacuum. It's happening inside the fabric, and the fabric fights back. The efficiency of the particle's engine is constantly battling two fundamental physical limits of the spatial fabric. First up is elastic resistance. Just like that twisted rubber band, the fabric naturally resists being deformed. This resistance sets the absolute baseline energy threshold required just to kickstart and maintain that internal rotation. Second, we have bendability. This defines the topological constraints. It basically dictates the maximum curvature the spatial geometry can handle before its structural integrity completely fails. So, how does this microscopic wrestling match actually build into the stuff we experience every single day?
Let's unpack that in section 3, radius, volume, and mass.
Okay, so the so what factor here is absolutely crucial. Radius equals mass. In this resonance framework, mass is not some magical property assigned to a mathematical dot. Not at all. Mass is an intrinsic mechanical property of the actual volume of fabric that is displaced, disformed, or kind of sucked in by the carrier ball. So logically, if you have a larger carrier ball, it displaces way more fabric. And because it's fighting that elastic resistance across a much larger volume, it requires a lot more energy to sustain those internal rotations. Mass is simply the measure of the energy required to hold a specific volume of contracted fabric in a resonant state. And actually, now that we understand mass as pure mechanical volume displacement, we can unlock one of the biggest mysteries in the entire Standard Model.
Which brings us right into Section 4, the 3 particle generations.
It turns out nature perfectly maps the particles we observe right into this mechanical logic. The Standard Model groups particles into 3 generations, right? So let's walk through them. Generation 1, that's your electron, your up and down quarks, and the electron neutrinos. These guys utilize the absolute minimum carrier ball structure. They have the minimum radius, the minimum mass, and because they barely even deform the fabric, they enjoy absolute stability. Then we step up to Generation 2, the muon, charm, and strange quarks. Here, the carrier ball expands to an intermediate radius. This increased volume contraction means a higher mass, and honestly, only transient stability. Finally, we hit Generation 3, the tau, top, and bottom quarks. This is the absolute maximum observed expansion of the carrier ball. It creates massive deformation, massive mass, and minimal stability. So when you really look at it, the muon and tau are essentially just highly stressed, totally overloaded versions of the standard electron.
And this hierarchy directly explains particle decay. You know, in the old model, particles spontaneously decaying into other particles can honestly seem a bit like magic. But here, particle decay is the logical, totally inevitable result of mechanical fatigue. As the radius expands in those heavier generations, the mechanical stress on the total volume of fabric just shoots through the roof. The fabric's bendability lessens, making the structure incredibly difficult to sustain. Stochastic decay happens simply because the mechanical engine of that massive carrier ball literally can no longer be sustained locally. The fabric just forcefully snaps back to a lower energy, less deformed state, throwing that excess energy outward. And this actually brings up a really profound architectural question about the universe itself.
Let's look at Section 5, the quantization mystery. So, this idea perfectly captures the core architectural puzzle of our universe. Why does the spatial fabric support 3 distinct families rather than a continuous spectrum of radii and masses? I mean, think about it. If the fabric can be deformed, why can't we have a particle that's, say, 1.5 times the size of an electron, or 2.7 times? Why are there only these 3 very specific, highly quantized rungs on the ladder?
Well, the resonant peak solution brilliantly illustrates the answer to this. These 3 generations represent the absolutely only specific, allowed geometric configurations where a state of semi-stable mechanical equilibrium can actually be reached. They are literal resonant peaks. At these 3 exact sizes, the internal belt trick rotations manage to achieve a temporary and sometimes incredibly fleeting synchronization with the fabric's elastic resistance. They are simply the only viable resonant states permitted by the strict mechanical limits of spatial geometry. And why is there no Generation 4? Well, current theory suggests that beyond the 3rd generation, the required radius would entirely exceed the fabric's volume contraction limits. The fabric physically just cannot stretch any further without instantly collapsing.
Which leaves us with this final, genuinely provocative thought. As we've seen, particles aren't just abstract math. They are real mechanical engines fighting a constant battle against the elasticity of space. And we've seen that the 3rd generation, like that massive tau particle, pushes the absolute mechanical limits of our spatial geometry. So, what exactly happens to the fabric in the exact precise microsecond a tau particle collapses under all that immense mechanical fatigue? What does that sheer violent snapback of the universe's fabric actually look like down at the absolute smallest scale? It's the kind of question that really shows us just how incredibly dynamic, violent, and physical our universe truly is. Thank you so much for joining me to explore the mechanical foundations of matter. I hope this explainer helps you see the universe in an entirely new, deeply physical way.